Good evening. My name is Jake Burch, and today for Team 4, we are presenting the Travel Desk Concept Combination Table. Here in front of you, we have a variety of solutions that have been developed from our concept combination table. We have our sub-problems here, being the adjustability, the folding of the legs, the material tabletop, and the legs locking in place. Tonight, I am going to tell you about the 6 solutions that our team has come up with. Starting with solution 1, developed by yours truly, we have the first solution. It is a hard plastic individual travel desk that folds together using a circular leg that screws together almost in a tripod-like fashion. So to fold together here, it is going to have a divot in the top of the table. So there's some thickness that's demonstrated here in the hard plastic top. And the individual legs themselves screw together as seen with the threads. And then there's a ball and socket joint, which is tentative, but it is what has been chosen to be demonstrated here. For solution 2, we have a wood scissor style. It's almost like a scissor lift. So the idea is the same with the top, that there'd be a kind of shell shape in there that the legs will fold up in, so that the space will be nice and ergonomic. And then here we have a locking pivot pin, so that when the table comes out, it locks into place. It's structurally sound. And then for the actual legs themselves, there is a hinge lock assembly inside of the lattice design. For solution 3, here we have Kevin's designs. We have the isometric composite tabletop. So here we go of a composite type design here. These are rectangular legs that fold together. It will have pins that lock them together. And then the bottom, there's an alternating approach for how these legs will fold together, which is similar to a card table if you've ever used one of those, but it is all inside of here. And again, all of these solutions fit within a backpack, which makes the design very ergonomic. Here for solution number 4, we have a soft plastic tabletop, which is beneficial to the customer since the top will be light and the product will be cheaper in theory. So we have a hinge design here, and these are actually like modular pins that lock the legs together. And for here, we also have a alternating design with the legs. For solution number 5, here we have Izzy Perham's solutions that were generated. We have a hard plastic polymer tabletop with a hinge with the pivot pins inside to lock the legs into place. The legs would be rectangular, telescoping fashion with push buttons similar to adjustable tables you may have seen in other areas. So kind of a depressed thing that would fit into a hole. And again, we have this alternating style here for what's going on with the legs. And for our solution number 6, we have an aluminum top that is a very sturdy top. It wouldn't experience any dings there. You see a folded design here that's going on. So again, these would all fit within inside of the tabletop. It's very important for the compactness of this. And we have a ball bearing hinge. A ball bearing hinge being similar to something you might see in a door hinge or something similar like that. Since there is a bearing assembly inside of it, these would be common, commercially available. They'd be very easy to find standard sizes for something like this. And then we have the manual locking pin, the hinge pins here, this design. So there is a scissor lift lattice shape for this design here as well, just a different style to lock these in. So to wrap up, these are the 6 solution concepts that have been decided on by the team. And all of these have features that could be potentially beneficial to the customer, and all of these bring good value. Thank you for watching.